Hello, it's a great pleasure to join this Mobile World Congress, and I only wish that we were able to get together in person, but hopefully that will be true in subsequent years. I speak as chair of the Energy Transitions Commission, which is a global coalition of companies from across the world, from America, Europe, India, China, Japan, all committed to making sure that we meet the conditions of the Paris Climate Treaty to limit global warming to well below 2 degrees centigrade and ideally to 1.5 degrees centigrade. And the science tells us that to do that, we have to get the whole world economy to net zero by mid-century, with all successful high-income countries getting there by 2050, while still developing countries get there by 2060. The good news is that technologically, we now know how to do that. And while there are several different relevant technologies, including bioenergy and carbon capture and storage, two are by far the most important, and they are electricity and hydrogen. The future is electric, and it is a world of great use of electricity and therefore great use of information technology to control electricity. And the key feature of all credible scenarios of how we get to a zero carbon economy is a massive increase in the role of electricity within our economies. Today, on average across the world, and it's also true in China, 20% of final energy demand, how we actually use energy in our businesses and in our homes, 20% comes from electricity. By 2050, that percentage will have to be somewhere between 50 and 65%. And that is driven by the relentless growth of some existing forms of the use of electricity in, for instance, air conditioners, and in information technology and all the servers that lie in the cloud that drive our mobile telephony and all our computing services. But we will also see the electrification of areas where we have previously used primarily fossil fuels, electric vehicles rather than internal combustion engines, and the electrification of residential and commercial heat. In those applications, one of the great things about electricity is that it is fundamentally more efficient. When you run an internal combustion engine, a diesel or a gasoline passenger car, you only turn about 25% of the energy into kinetic energy to drive the car forward. 75% is completely wasted in heat that you don't want. For electric vehicles, that efficiency percentage is over 90%. So a more electrified economy is going to be more energy efficient. But even more so, it is going to require much more electricity. Across the world at the Energy Transition Commission, we believe that total electricity use will go from 27,000 terawatt hours globally today to somewhere between 70 and 90,000 terawatt hours electricity in direct use by 2050. In China, electricity, which today is about 7,000 terawatt hours, could reach 15,000 terawatt hours by 2050, as China develops to become a fully developed high-income country. To meet climate objectives, of course, all of that electricity must be produced in a zero carbon fashion. And the good news is that we now know how to produce electricity in a zero carbon fashion in a way which is fully competitive with fossil fuels. That reflects the collapsing cost in particular of renewable electricity, with the cost of wind power down 70% over the last 10 to 12 years. Solar falling even more, its costs coming down 80 or 85%. And those cost reductions will continue. And in most parts of the world, including China, including India, including most of the developing world as well as the developed, renewables are now the cheapest way to produce a kilowatt hour of electricity. So that the major problem we now face in building a zero carbon economy is no longer how to generate electricity both cheaply and in a zero carbon fashion. We know how to do that, but it is what to do when the wind doesn't blow and the sun doesn't shine. How to balance supply and demand in future electricity systems with time varying supply and time varying demand. Part of the answer to that will be two other zero carbon technologies, hydropower and nuclear power, particularly if we can make nuclear power plants more flexible, which is a technology which is being developed. But three categories of flexibility will be particularly important: batteries, hydrogen, and digital integration. As batteries get ever cheaper, they will play a role in balancing the system over the short term, day to night and day to day cycles. If China in 2050 produces and consumes 15,000 terawatt hours per annum, that is 41 terawatt hours per day. And if 20% of that supply had to be stored and then released later to meet the timing of demand, that would require 8 terawatt hours of batteries, and equivalent across the rest of the world as well. And it's absolutely possible to meet that demand in China and globally with the available mineral supply and with effective recycling of batteries. But while batteries are good for the daily cycle, continually on 365 or even more cycles a year, storing and then releasing energy, they will be too expensive to support the much less frequent seasonal cycle, the storage and then release of energy a few times a year to balance seasonal periods of excess supply versus excess demand. And here we need multiple technologies. There is possible use of liquid air and compressed air, pumped hydro storage, and other forms of gravity-based systems. But a particularly important role will be played by hydrogen, created via electrolysis when renewable energy is in surplus supply, and then burnt in gas turbines to produce electricity when we need it. And if China in 2050 has 15,000 terawatt hours of electricity production and supply, and if 20% of that has to be shifted across the year, 3,000 terawatt hours, then at 50 kilowatt hours per kilogram for electricity, that implies 60 million tons of hydrogen, compared with 30 million tons that China produces today. And whereas today, almost all of that 30 million tons is made in a dirty fashion from coal or gas, in 2050, all of that hydrogen will have to be produced in a zero carbon fashion, primarily via electrolysis. And across the world, our estimates suggest that total hydrogen production, which is currently about 100 million tons, with only about 2 or 3 of that produced by electrolysis, that will have to grow to somewhere between 500 and 800 million tons by mid-century, and the vast majority of that made by electrolysis. So we do have the technologies to take the supply of clean electricity and shift it across the day and the year to meet demand. But there is also a crucial third technology, which is digital integration, which will enable us to manage the timing of demand more intelligently using complex, sophisticated, software-based control systems to manage the demand for industrial processes, for commercial or residential heating, for the use of computing power, whether we are talking about that decentralized within offices or in large cloud-based server farms. Varying demand in response to available supply will be crucially important. And it will be crucial that we integrate into our storage systems the huge storage capacity which will be made available by electric vehicles. I said earlier that if China has in 2050 15,000 terawatt hours of annual supply and demand, which is 41 terawatt hours per day, it might need 8 terawatt hours of batteries. And that might seem like a lot of batteries to have to go and buy and install to support the balance of the system. But if China in 2050 has 300 million electric vehicles on the road, each with 60 kilowatt hour batteries in them, that would in any case be 18 terawatt hours of battery capacity already paid for, sitting around doing nothing in parking places and garages, far more than is needed to balance the system. And it is therefore vitally important that we think through intelligently how to use that capacity. Because if everybody simply charges their electric vehicle at any time of the day and night without thinking about it, that will impose huge storage and flexibility problems on the grid. But if we can persuade people through clever software and clever business systems to charge their electric vehicles at sensible times at the day or night when electricity is in surplus supply, or indeed to make their batteries a source of storage capacity to the grid with vehicle to grid integration, that will hugely reduce the costs of getting to a zero carbon economy. So I am confident that we do know how to build zero carbon economy, and the core is electricity. I'm confident that we know how to make electricity systems which are far bigger than today and zero carbon. And I am confident that we have the mechanisms of storage and flexibility to make those systems balance, even though we have excess supply at some periods of the day or year relative to demand. And one crucial tool of that, which I think is important to everybody involved in the mobile world, the world of telecoms and the world of IT, is the application of digital technology to enable us better to balance supply and demand in this deeply electrified world. Thank you very much. I wish I was with you, and I hope the rest of the Congress is a very great success. Thank you.